For our second example, we're going to be looking at average daily spending in the U.S. The polling that Gallup does measures everything from every 3 days to every 7 days and asking people, well, how much have you spent in the last 3 days? How much have you spent in the last 7 days? They do that in order to avoid like one day that's peak and then 2 days that are lower. So by averaging them, they try and level it out a little bit. This data is actually looking at spending during Thanksgiving week in 2017, and I want you to notice it's a mean problem because it says average. And I want a confidence interval because I want 95% confidence, but also based on what we're trying to find. That is, I want to figure out, well, what does everyone spend on average during Thanksgiving week? I'm trying to make an inference about everyone. I'm not trying to prove a conclusion, which means I want to do a confidence interval. So first step, whenever I do a confidence interval, is to go ahead and list everything. I'm going to list X bar, I'm going to list S, I'm going to list N, I'm going to use that to find degrees of freedom, and use degrees of freedom to find a t-score. My average here is $115. So on average, they're saying during this week in 2017, people spent about $115 per day. Now the standard deviation of this data set is 388.35, and that should cause you to hesitate a little bit. That is an enormous standard deviation, especially compared to our average. We're saying on average people spend 115, standard deviation is 388. What this is telling us is that people were really spread out. Specifically, if you look at 115, we can't really go 388 below that, right? This tells us that our data has a definite right skew, which we tend to have with spending. That is, there are some people out here whose turkeys are really well off. That is, they're spending a ton of money during that week. Well, back here, we have an average of 115. Now remember, with skewed right data, the mean is always above the median, which means that our 50% division is actually even further below that. Understanding the shape of our data is really important, not only in the process we're taking right now, but also in the way we're going to discuss our results with other people. Getting back into this problem, N is 2,956, which means my degrees of freedom is going to be one less than that, 2,955. To find my t-score, I need to go ahead and put in my t-tables, so, ta-da, there it is. Just like before, we're going to go ahead and we're going to start by finding our confidence level on the bottom, 95%, and tracing that up. I want to be in this column right here. And then I'm going to come over here and I'm going to find my degrees of freedom. Now, I've got degrees of freedom 2,955, which means when I look down here, it's not exactly there. Now, normally, if our degrees of freedom is not on the table, we will always round down. For instance, if I had degrees of freedom 95, it wouldn't be on the table, so I'd go ahead and I would round down to use 80. In this case, though, our degrees of freedom is very large. And so in our class from here on out, if we have degrees of freedom over 1,000, we'll use the last row, which is actually the z-table. So coming down to that last row, then I'll trace this over, and notice, sure enough, that when I have degrees of freedom that large, I'm getting a t-score of 1.96, which is what we talked about before. That is, for large degrees of freedom, the t-distribution is actually just the normal distribution. Now that I have all this information, I'm going to go ahead and start my second thing, which is my calculations. The only calculation I need to do is SE, which is S over root N. And keeping two decimal places for that, in this case, we're going to get 7.14. The difference between SE and the standard deviation I have up here is this standard deviation is from my sample. That is, this is the standard deviation between people. This number right here is the standard deviation estimate, so it's not actual standard deviation, of samples. That is, if I took a whole bunch of samples of 2,956 people, how much variation do I see between those samples themselves? Not every sample would have an average of 115, some might be higher, some might be lower, so this is the estimate of how much variation I would see between samples. Step 3 is my interval. When I go to calculate my interval, I'll take x bar plus or minus t times SC, keeping 2 decimal places in this, lower of 101.01 and upper of 128.99. Our final step is always to go ahead and summarize our results. So in this case, we're going to say we are 95% confident. Hopefully you're noticing a theme now on which confidence interval we're sticking with. That the true average, and we'll say what, daily spending during Thanksgiving week, and we're being specific here because spelling during Thanksgiving week is probably different than, a week in May or Christmas week. Is between $101.01 and $128.99. Notice I've got all my important information here. I've got how confident I am, what I'm talking about. It's an average of daily spending. When or who, well, during Thanksgiving week, is between 101 and 128.99. Another piece of information I could put in here is the fact that I'm talking about Americans. So I could say that the true average daily spending for Americans during Thanksgiving week is between 101 and 128.